In this video, we are going to continue with the Old Faithful eruptions data and find the confidence interval for the slope. In the top half of the page here, we have all of the data table for a random sample of 20 eruptions. We have the scatter plot, the residual plot, histogram of the residuals, and the computer output from StatCrunch. We also just have in this red box just a reminder of some of the things that we did in Chapter 3. So that's just kind of there for you to look at. I'm really not going to talk about that much. Now, down here, we have the output for the INSPIRE linear regression t-interval. And I want to show you where some of the important numbers come from as we construct our confidence interval. So we are going to estimate the population slope using a 95% confidence interval. In a previous video, we've already checked the conditions, so we're just going to go straight to the do step. Now, recall that when we do a confidence interval, we take the sample statistic plus or minus a t or z critical value times the standard error of the statistic, in this case, the slope. So we are going to do our sample slope plus or minus t critical value times standard error of the slope. So we need to know how to find those three important numbers. In the INSPIRE printout, B is our slope right here. Standard error of the slope is right here. Also, degree of freedom being 18 is an important number that we're going to use. If we go up to computer printout, it's usually in table form. And in the table, in the bottom left-hand corner is usually the x value. This says slope. Sometimes it would have the name of the x value. In other words, it would just have duration, and it would say coefficient, like the coefficient of the duration would be the slope. So this is our slope right here, and then our standard error of the slope is right next to it. We'll look at some other computer printouts of data too. This is actually not as typical of some other things you would see, but usually it's in the same position. Once again, and then we have our degree of freedom is 18 right here. Probably should have circled that. I think I have it circled up above, but that's also important. Okay, now when we come down here then, how do we find the t-critical value? Well, if we look at a t-table, we want to look at the column for 95% confidence and the row for 18 degree of freedom, and there's our t-critical value. Very simple. We can also use inverse t on the calculator by cutting off everything below the upper tail of the 95% confidence interval. So this would be 0.975, the 0.95 plus the 0.025 in the left-hand tail, comma 18. That would also give me 2.101. I personally think the table's easier. Once we have our values, then these two multiplied together are a margin of error, which we actually have listed for us on the INSPIRE printout. That looks very reasonable because we have about 2.1 times about 1.9, and that's really close to 4. Then we also have the lower and upper bounds of our confidence interval. If you do this on your calculator, you'll find that it matches this. It's a little, it might be off by a decimal place or something, but it's really close because we have things are rounded differently in different places. And now we have our confidence interval, and we can conclude we are 95% confident that the interval from 6.38 to 14.42 captures the true slope of the line relating the interval of time until the next eruption, y, to the duration of the eruption, x, for eruptions of the Old Faithful geyser. So basically you're saying we're 95% confident that the interval from blank to blank captures the true slope of the line relating the y variable to the x variable for whatever our context is. Now let's take a minute and look at how we would do this on the graphing calculator. Here we have the data loaded into two lists in the calculator, and I also named another list called Old Faithful residuals. Okay, now we're going to be using that later. Now I'm going to insert a calculator page and do a regression. Actually, maybe I should, before I do that, I'm going to go ahead and do a data and statistics page and do a regression here. So I am going to have my duration as my x-axis, my interval is my interval is my y. So we can see here a scatter plot of the data, and we can use this to check the linearity condition. We can also do a regression on here. If we go to Menu and Analyze and Regression, and then go to Linear, we can do a regression right on here. We can also create a residuals plot. If we go to Menu and Analyze and Residuals and Show Residual Plot. Now you have to do a regression before you can do the residual plot. So here's the residual plot. Now I can also show a residual plot separately, and I'll show you how to do that in just a minute. So let's go to a calculator page now. I prefer to do the linear regression on the calculator page because I think it's easier to navigate and to read. So I'm going to go to Menu, Statistics, Menus, I'm not sure why it's doing this. Okay, Menu, Statistics, confidence intervals, 6, and notice we have no, it's not letting me do what I want to do here. So I'm going to go to confidence intervals here and linear regression t interval. I'm going to do it for the slope. We put in our x list, which is duration, the y list, which is interval, and confidence level 95%. Okay, and here's this is the printout that we got that was on the paper. Now there's the residuals are all stored in a list that you can access under the variable button. If you go to stat resid, okay, there's a lot of stuff in here, so I got to scroll down a bit. Stat resid right here. And then the reason I already created a list name was so I can store my residuals to that list name. So I called my list Old Faithful, oh there it is, Old Faithful Residuals right there. And so now I push enter, and when I go back to my page that had the data in it, okay, see I can see my list of residuals. Now that's going to allow me to make plots of just the residuals. So I can go to data and statistics, and I can make a bigger residual plot by putting the x value on the x-axis and the residuals on the y-axis. Okay, so that makes a bigger residual plot. I can also make a residual plot, so I can do just residuals here, and here's a dot plot of the residuals. I can also change this to a histogram of the residuals. Okay, now notice that looks a little different than the one I have on the paper. If you hover over the edge here and hold down until the hand appears, you can actually just drag until you get bars that are fewer bars, which actually makes, oh dang it, I did this before and this froze my program, so I will be back. Okay, for some reason my program on my computer gets to this point where it freezes if I pull the bars too far out for some odd reason. Okay, so if I pulled the bars out a little bit, and now if I go to Menu and I go to Zoom Data, it kind of recenters it. Okay, so now I have a nice looking histogram to sketch on my paper if I were checking this and show that the histogram of my residuals looks approximately normal. If for some reason I don't have very much data and it's hard to make a nice looking histogram, I could also go to do a normal probability plot and notice that it's fairly straight. So those are some options I have. Let's see if there's anything else I need to show you on the Inspire. Oh, I guess not. I think that's it. I think I've shown you how to do the confidence interval test and all the different graphs that you need to see. You've done the linear regression interval, and so it's really pretty simple, pretty straightforward things you've done before.